Hello and welcome to Math 111. Here is our first video on section 3.1, functions and function notation. Now these notes that I'm basing this video on, or we're looking at right now, are available for you to print out and follow along with. If you don't have access to a printer, that's fine. Just get out a notebook and take notes along in your notebook as you watch this video. You'll get a lot more out of the video if you do follow along and write things down as opposed to just listening. So what are we going to try to learn in section 3.1? Well, we're going to determine whether a relation is a function. We're going to find values of a function. We're going to determine whether functions are one-to-one. We're going to use vertical line tests to identify functions. And we're going to look at the toolkit functions and decide which of those are one-to-one functions. So that's our plan of what we're going to do in this video today. All right. Step number one, let's determine whether a relation represents a function. Well, first, maybe we should recap about what a relation is. A relation is a correspondence between a first set, which is called the domain, and a second set, which is called the range. So what is a domain? That's a vocab word. A domain is the set of all inputs. And the range is the set of all outputs. So if we think about a relation in a real-world example, let's think about a piano. Every key on the piano corresponds to a musical tone. So in this relationship, the input, the domain, is going to be the keys on the piano. You can play any key you want. And the output is going to be the musical note. So you press on the key, that's the input, musical note is the output. So that's just a relation. So let's think about a special type of relation that we call a function. And a function is a relation in which each input value leads to exactly one output value. So the idea is it's a machine, or one example I like to use is like a vending machine. So if we think about a vending machine, here's my bad drawing of a vending machine, and on the vending machine are buttons. There's maybe a button for Coke. There's a button for 7-Up. Maybe there's even a button for water. The input to this machine is your button press. You push the button for Coke. The output is a bottle of Coke. Or drinks, I guess I'll say, because I put water on there. I can't even say soda. So my input is a bottle of Coke. My input is the button, and my output is going to be a bottle of Coke. So what does it mean? Each input leads to only one output value. It means there isn't a button that you push and you could get Coke half the time, or you could get 7-Up half the time. If you push Coke, you know you want Coke and you want that to come out. So that's the idea between a function. You know what you're going to get when you push the input button, and you get the same thing every single time. So that's sort of a real-world conceptual example. Let's look at an example using set notation. So here is my function in set notation. Each input and output is an ordered pair. So my input is the first value in the ordered pair, and my output is the second value in the ordered pair. So if I input -2 into this function, I get +2 out. If I input 0 into this function, I would get 2 back out. All right, so in this example, what is my domain? Well, remember, your domain is the set of all inputs. So which ones are my inputs? The first value in each ordered pair. So those are my inputs, -2, -1, and 0. And I'm putting them in set notation, which is just a way of listing items in no particular order. Now the range is your set of outputs. So what is my range in this example? I can't find my pencil thing. Where is it? Oh well, I guess I'll just keep using blue. My pen choice disappeared. My range is my output values. I'll draw a box around those. So my output, well, it looks like every single one is 2, so it's the set of 2. Now, this may seem like a problem because every single button pushes to 2, but that's okay. We know we're going to get 2. We don't get 2 half the time and 0 the other time. And if we thought about it in a real world scenario, this would be like that vending machine that's just all water. No matter what button you push, you get water, but it's okay because you know what you're getting when you push the button. All right, So here's one I want you to try. This is a table representation of a function. My input is in the top row, and my output is in the bottom row. And I want you to look at this table and decide if it represents a function, and if it doesn't, fix it. So pause the video right now and decide if this is a function, and if it is not, fix it. All right, well, I hope you guys are back from pausing the video. As you can see, it's not a function. So does this table represent a function? No. And why not? Because there's two choices for Harry Potter. Harry Potter could go to Voldemort, or Harry Potter could go to Dolores Umbridge, right? That's not going to be a function because we don't know if we're going to get Voldemort or Dolores Umbridge out when we push the Harry Potter button. So how could we change this? Well, maybe we make Harry Potter, the first Harry Potter into Harry Potter 1, and we'll make the second one was Dolores Umbridge, I think, in Harry Potter 5. And now we have different inputs. So Harry Potter 1 gives you a villain of Voldemort, and Harry Potter 5 gives you a villain of Dolores Umbridge. Thinking about this, what would my domain be? Well, those are all my inputs. So that would be a Little Mermaid, 101 Dalmatians, Harry Potter 1. Oops, I almost spelled Harry Potter wrong. That's embarrassing. Got excited there. Harry Potter number 1 and Harry Potter number 5. And my range is going to be Ursula, Cruella, Voldemort, and Dolores Umbridge. All right, so we took a table that was just a relation and not a function, and we fixed it so that it became a function. All right, so what I would like you guys to do is practice right now and look at these three tables and decide which of them are functions and which of them are not functions. Pause the video and decide. All right, you're back from the video. Let's take a look. The first one is indeed a function. 0 goes to 3, 1 goes to 5, -1 goes to 1. Yes, it's a function. There's no repeated inputs that go to different outputs. Number 2 has got some problems, right? When we push the -1 button, we don't know if we're going to get a 3 out or we're going to get a 1 out. So no, not a function. And what about the last one? Is it a function? Yes, it is. You get 0 every time, but that's okay. 0 gives you 0. You know you're always going to get that. All right. So to decide if a graph represents a function, we're going to use something called the vertical line test. And the vertical line test says if you can draw a vertical line that touches the graph of a relation more than once, that graph does not represent a function. And let's see if we can kind of reconcile that with our previous definition of what is a function and what isn't a function. So let's look at the example of the last one here. Let's start at the last. We're going to look at the circle. If we look at this input value here on the x-axis, this is at x equal to 3. And if we look at x equal to 3, we have two output values. We have one up here at +3 and one down here at -3. So if we put in the input, so that's my y is equal to 3, y equals -3. If I built this into a table and I put x equals 3, well, one output is +3 and another one is -3. So I can see right there, relaying that back to my table definition, that that is not a function because 3 both goes to 3 and it goes to -3. And that's how the vertical line test works. If you can draw a vertical line that touches the function twice, that means it has two output values at that input. So for example, let's look at one that isn't 3 and -3. Let's draw another vertical line on this one right here. My input here is at x equal to 1, but I have an output of +2, and I have an output of -2. So that is also not a function because +1 input could lead to two different possible outputs. My first guy is a function. Any vertical line I draw is not going to hit that graph more than once. All right, last way of deciding if something is a function, let's look at its equation. We're being asked here is t a function of v? So the first thing we're going to do is we're going to solve this equation for t. So we want to know, is t a function of v? So to solve this for t, we're going to add 5 to either side to isolate t by itself. So t equals v squared minus 1 plus 5 is plus 4. So t equals v squared plus 4. Let's rewrite this. T equals v squared plus 4 over here, just because I like to have the output variable on the left-hand side for whatever reason. And maybe you guys recognize this. I hope you do. This is actually a quadratic equation. Here's my quadratic, v squared plus 4. It would actually give you a parabola that looks like this. And we can see that would pass the vertical line test, but we can also see that no matter what we put in for v, if we wanted to fill in a table, no matter what we put in for v, we would get a unique t out. So if we put in 0 for v, we'd square it plus 4, get 4. If we put in negative 1 for t, we square it, we get 1 plus 4 is 5. And you can fill out the table and see for yourself that no matter what v you put in, there's only one way, only one t that you're going to get out. Let's look at this one. Is t a function of v when v minus 1 equals t plus 5? Again, let's go ahead and solve. So this gives me t equals v plus 4. And hopefully, let's rewrite this guy. T equals v plus 4. This is the equation of a line with slope 1 and y-intercept 4, which also is going to pass the vertical line test. All right, so that's wrapping it up for this video. I'm trying to keep these guys at about 10 to 12 minutes long. Go ahead and stop this video, and then we're going to continue in the next video with more information about 3.1.